Hi everyone, welcome to today's video lesson on factoring simple trinomials. Go ahead and grab your notebook and title the top of the next available page so that you can take notes along with this video. Now if you remember, we started our factoring unit with the GCF. The greatest common factor is a method that you can use for binomials, trinomials, polynomials that have 4 terms, 5 terms. It works for all of them as long as your terms have something in common. Then we focused our attention a little bit more direct to binomials when we talked about dots, or the difference of 2 squares. We're going to move forward now and talk about trinomials. So hopefully you remember that trinomials are polynomials that have 3 terms. And for today's lesson, we're going to talk about simple trinomials. And yes, there are more advanced trinomials, and we'll work with those in the future. So for today's lesson, we're going to be working with quadratic trinomials, so things that have an x squared in them, and they're all going to fit this format of ax squared plus bx plus c. Okay, that's the standard form of a quadratic trinomial. Now the thing that's going to make these trinomials, or the examples we work with today, simple is that our a value is going to be equal to 1. So all of the examples I go through today are going to start with 1x squared. I won't write the 1, but if you do write the 1, it means the same thing. Okay, so hopefully by the end of today's video, you're going to be able to factor a trinomial that maybe looks something like this. Ax squared plus 8x minus 36. Remember that a is equal to 1, so here's an example. Okay, but before I get into the actual process of breaking this down into its 2 factors, I love to show you guys the fact that factoring is just the reverse of multiplication. So let me show you some multiplication problems that result in these simple trinomials, and we'll see if you can pick up on any of the patterns. Okay, the first one is going to be x plus 2 times x plus 5. The second one is going to be x minus 4 times x minus 1. And the third one is going to be x minus 6 times x plus 3. Okay, now hopefully you remember how to multiply these. If you would like to pause the video, try them out yourself, go for it. But the first one here, remember we're going to double distribute because we've got a binomial times a binomial. So x times x is going to give us x squared. X times 5 is going to give us 5x, and then I repeat the process with the 2x plus 10, and I simplified putting it into standard form. So with the 5x and the 2x in the middle, I can combine like terms to x squared plus 7x plus 10. If I repeat the process for number 2, I'm going to get my x squared minus 1x minus 4x plus 4. That's when I double distribute the x and double distribute the negative 4. And combining like terms in here, negative x minus 4x is negative 5x. And last but not least with number 3, multiply it out, you get x squared plus 3x minus 6x minus 18. And when you combine like terms there, you get x squared minus 3x minus 18. Okay, so hopefully you might have picked up on a pattern or two. The first one that I notice is that all 3 of my examples are multiplying 2 binomials together. So that tells me when I'm dealing with these trinomials and I'm working to factor them back, probably going to get 2 binomials that multiply together. You'll notice that all of our examples have factors that start with the variable x. Okay, well that's because x times x is the only way to get x squared when we multiply. So that's a good sign when we're working with these simple trinomials. If it starts with 1x squared, it probably means that both of my factors are going to start with 1x. Okay, now all 3 of these examples had 2 like terms in the middle that we added together, and it had 1 constant on the end that stayed the same. Do you notice any patterns between the numbers that are on the ends and the numbers that are in the middle? Well, in this example, the 5x and the 2x added to 7x. But the 5 and the 2 were also the numbers that were in my factors. So these two numbers add to 7. These two numbers add to negative 5, and these two numbers add to negative 3. So that's something that I can use to my advantage. If I'm working backwards, I know that the two numbers in my factor have to add to this middle term, our b, what I'll call it. Last but not least, this number on the end is very important to us because it is the multiplication of the two constants in our factors. So 2 times 5 gives us 10. And negative 4 times negative 1 gives us positive 4. And negative 6 and positive 3 gives us negative 18. Okay, so there's a lot going on here, but 3 key patterns that we're going to use to our advantage when we're working in the opposite direction. Okay, so let's look at an example of what we're actually going to be doing when we're asked to factor one of these trinomials. Okay. Number 1, x squared plus 5x plus 6. Okay, when I'm asked to factor this trinomial, I'm being asked what two things are going to multiply together and give me this as a result. Well, again, if I use the patterns that we saw here, I know that the only way to get x squared is to have an x in the start of both of my factors. So I'm going to open up parentheses similar to what we did when we worked on dots. And I'm going to start both of them with 1x. Again, that's going to get me the x squared when I multiply x times x. Now, the numbers that are going to fill in my factors have to do two things for me. They have to add to the positive 5 in front of the x, and they have to multiply to the positive 6, that's our constant on the end. So if you think about the numbers that add to 5, there's a lot of them, right? And especially when we take into consideration both positive and negative numbers, we could sit here for hours and list all the combinations that add to 5. So the easier way to do this is to start with this fact. I need two numbers that multiply to positive 6. And a lot of times you'll see me come off to the side and I'll give myself a little chart and I'll list out all the factors of 6 or all the numbers that can multiply together to give me positive 6. Now I'm going to put a little positive there just to remind me that. So I've got positive 1 times positive 6, positive 2 times positive 3, and I'm looking for which row or which combination is going to also add to 5. So 1 and 6 make 7. And 2 and 3 make 5, and that means that 2 and 3 are my magic combination. Now, if you do this correctly, if you list out the correct factors and you add them together correctly, there is only one pair of numbers that's going to do both jobs at the same time. So if I know I need to use a positive 2 and a positive 3 to multiply to 6 and add to 5, then that means that my positive 2 and my positive 3 are the constants that are going to fill out my factors. Now, remember, multiplication is commutative, so if you wrote x plus 3 and then x plus 2, you got the right answer because you're still multiplying your two factors together. Let's look at another example. Am I going to be able to squeeze this? Yeah, let's squeeze it next to it. Okay, x squared plus 2x minus 24. So again, we've got a simple trinomial because there's a 1 in front of my x squared, which right away tells me that my factors are both going to start with 1x. It's the only way to get x squared. The question is, what two numbers are going to add to positive 2 and multiply to negative 24? Now, it's important to recognize that it's a negative 24 because two numbers that multiply to a negative have to have opposite signs. So if I go over again, for me personally, it keeps me organized to write a little chart. I might have 1 and 24 with one of them being negative, so maybe negative 1 and 24 or positive 1 and negative 24. Or I could have negative 2 and positive 12, or positive 2 and negative 12, or I could have negative 3 and positive 8, or positive 3 and negative 8, or negative 4 and positive 6, or positive 4 and negative 6. And that's a lot of factors. So I'm going to go through this list and I'm going to check row by row which combination is going to add to the positive 2 that I want. Okay, now maybe you've been yelling at your screen for the past 30 seconds because you already know which two numbers are going to add to positive 2. If you did, that's awesome. Okay, but just to show you guys that there's only one combination that works, let's go through all of them. Negative 1 and positive 24 add to positive 23. Positive 1 and negative 24 add to negative 23. Negative 2 and positive 12 add to 10. Positive 2 and negative 12 add to negative 10. Negative 3 and positive 8 add to 5. Positive 3 and negative 8 add to negative 5. Negative 4 and 6 add to positive 2. And positive 4 and negative 6 add to negative 2. So here's my magic combination. Okay, do you have to write out this list every time? No. Is it going to help when you have a number that has a lot of factors? Definitely. Okay, but your calculator can also be used to check what two numbers multiply to negative 24, and then you can use those two numbers to add them together. Okay, as soon as I recognize though that I have my magic combination, I fill in my factors with negative 4 and positive 6, and voila. X plus 4 times x plus 6 is the factored version of x squared plus 2x minus 24. Okay, keep in mind, just like with all factoring problems, your answer can be checked by multiplying it back out. If I double distribute the x minus 4, I should get this trinomial up here as an answer. If I didn't, then I either made a mistake in my multiplying check process, or I made a mistake listing out or adding up my factors. So it's definitely helpful if you're handing in a homework or a quiz or a test and you want to make sure you got it right, multiply it back out. I'm going to go ahead and write down 2 more examples for you guys to practice. Again, feel free to pause the video and try them on your own. The best part about these videos is no one's around to see if you got them right or wrong. You're checking for yourself, and if you get them wrong, then you're going to know that you need more practice. If you get them right, then you know that you got the hang of this. So number 3 is going to be x squared minus 8x plus 15. And number 4 is going to be x squared minus 3x minus 4. All right, so let's start over here. I have my simple trinomial with a 1 in front of my x squared, so my factors have to start with 1x. And I want two numbers that are going to add to negative 8 and multiply to positive 5. So with, positive 15. So with positive 15, I've got combinations like 1 and 15. 3 and 5, but none of those add to negative 8. The important thing to remember is that not only do two positives add to multiply to a positive, but also two negatives. So I could add negative 1 and negative 15, or negative 3 and negative 5 to the list, because those also multiply to positive 15. And in this case, my negative 3 and my negative 5 are going to be that magic combination that add to negative 8. I didn't have to worry about the negative combinations up here in our first example because I was adding to a positive number. But if you're multiplying to a positive and adding to a negative, you're adding two negatives together and multiplying two negatives together in order to do that. So I'm going to use the negative 3 and the negative 5 in either order. So if you wrote x minus 5 times x minus 3, you also got it right. And I'm going to check it by multiplying it back out to make sure I get my original trinomial. Let's try the last one. X squared minus 3x minus 4. It starts with 1x squared, so my factors are going to start with 1x. What two numbers multiply to negative 4 that also add to negative 3? A lot of people right away think of 2 and negative 2 when they think of negative 4, but those don't add to negative 3. And don't forget, every number has factors of 1 and itself. So I can also get negative 4 by multiplying negative 4 and positive 1 together. And if I check those two factors and add them up, I get negative 3. So my two constants in my factors are going to be negative 4 and positive 1, because those are the only two numbers that multiply to negative 4 and add to negative 3. Okay, so that's what it means to factor a simple trinomial, and that's as far as I'm going to go today. Make sure you bring all of your questions to class and see if you can try this problem. If you get an answer, bring it in, and we'll see if you got it right. I'll see you guys in class.